All right, guys, Mr. McDonald here to talk to you today a little bit about cellular respiration. All right, we're not going to cover cellular respiration in all of its details, but we're going to talk about it a little bit. And this is where we left off. Okay, so we've been talking about ATP and the storing of energy in adenosine triphosphate. And that kind of begs us to ask the question, well, where does the energy come from? And thinking back to what we know about energy and the laws of thermodynamics, energy can't be created or destroyed. It can only be transferred. So what process transfers energy to ATP? All right, and that process is called cellular respiration. And the bottom part of this slide is really important because it's a part that pops up on your Keystone exams. And I don't know if you guys will ever have to take your Keystone exams or when it'll be, but they commonly ask if cellular respiration happens in both plants and animals. And in fact, it does. The common mistake that's made there is kids say that cellular respiration only happens in animals and photosynthesis only happens in plants. And that's just not true. Cellular respiration happens in both. Although animals cannot undergo photosynthesis, plants and animals can undergo cellular respiration. So if it happens, don't get tripped up on that question. All right, so let's learn a little bit about cellular respiration. All right, what we're going to get into today is the pathways that require oxygen. All right, not all of cellular respiration requires oxygen, but that's not what we're going to focus on. All right, so glucose is oxidized and O2 is reduced, and we'll talk a little bit more about that, but we're really not going to use those words all that much because I think it'd be a little bit confusing. All right, so glucose, the breakdown of glucose is therefore an oxidation reduction reaction, which if any of you guys take chemistry, you guys will talk about oxidation reduction reactions. We're going to touch on them a little bit, but not a lot. All right, so what do we get from one glucose molecule? All right, so again, back in chapter 2, we learned that glucose was a simple sugar. It's a carbohydrate. So it's just a one ring of carbons. All right, it's C6H12O6. And for every one of those, we manage to get 36 to 38 ATP molecules. And that's the most that we can get. That's the complete breakdown of glucose. We can't do any better than that. So in essence, what cellular respiration is we're going to take glucose apart. We're going to get rid of the carbon, we're going to get rid of the hydrogen, we're going to get rid of the oxygen because we don't want any of those things. All we want is the energy that's stored in the bonds. Okay, so that's what we're going to do. We're going to dismantle a glucose molecule to get the energy that's stored in its bonds. All right, so overall equation. Let's bring these things in here. So one molecule of glucose plus oxygen that we inhale gives us carbon dioxide, water, energy, and electrons, and 36 to 38 ATPs. Okay, so again, all this comes from breaking this down. Okay, we want to break glucose apart again just to get the energy. That's all we want. And looking at this, the CO2, what do we do with CO2? We exhale it. We don't do anything with it. Okay? The H2O, what do we do with H2O? Well, we sweat it out. When we go to the bathroom, we get rid of it. And we don't use the H2O from here. Again, we're getting rid of the C, the O, the H, and the O. We'll talk about what happens to the electrons. And obviously, we need the energy. We need the ATPs. Okay, so what type of process is this? Again, we said it's an oxidation reduction process, or what's called a redox reaction, if you guys ever do chemistry. All right, so what oxidation means and what's important is that we remove electrons from glucose. All right, so let me say that again. All oxidation means, for what we're learning, is that we remove electrons from glucose. And we're going to see that that's really important because we do something with the electrons. Okay? And the reduction part is those electrons eventually go to O2 and H2O. So they gain electrons, which is what reduction means. Okay, so that's what we got going on. And again, I'm trying not to focus so much on that, even though it keeps popping up here. All right, so what carries the electrons? Well, there's these molecules called NAD+, all right, and they gather the electrons and they gather the hydrogens. Okay, so what we see is it's a coenzyme, and when we break down, let's see, where's my picture here? When we break down glucose, this molecule, the NAD+, is going to pick up a hydrogen, become NADH, because we added hydrogen, and it's going to pick up an electron. An electron has a negative charge, okay? And that negative charge cancels out the plus, and there's no charge over here. So this is the oxidation part. This is gaining an electron. All right. FADH does the same thing, and again, you're getting a lot of chemicals that I'm going to try and show you guys what they do, but it does the same thing. It picks up hydrogens and it picks up electrons. All right, so again, this is how we break down our carbohydrates, like glucose. All right, it gives off energy. All right, and our glucose is broken down into carbon dioxide, water, and into ATP. All right, so it's said to be catabolic because it breaks. Because it breaks glucose into smaller molecules. Those were vocab words that we had. We had anabolic, which built things up, and catabolic, which broke things down. All right, so let's check this out. So the first part of cellular respiration. So we're going to attempt to use all that information that you've kind of picked up so far. So the first thing that we have is glycolysis. And glyco implies glucose, and lysis implies to break down. And literally all that happens in glycolysis is we tear glucose in half. Imagine getting a piece of paper and tearing it in half. Okay? Then we plug those halves into the Krebs cycle. And then we take parts from the Krebs cycle and plug them into the electron transport chain. Those are the three parts of cellular respiration. Okay? So again, we're going to try to work our way through those, and we're going to try to use the NADHs and the FADHs in here. So that's why we kind of talked about those first. Okay, so where does cellular respiration take place? Well, it happens in the mitochondria. Okay, so this was an organelle that we talked about last week. All right, so we have glycolysis happening in our cytoplasm, and then our Krebs cycle and our electron transport chain happens inside our mitochondria. All right, so again, mitochondria is the where. All right, so if anyone asks where cellular respiration happens, the correct answer is the mitochondria. All right, so again, check out some more of that. All right, so we're just going to talk a little bit about the mitochondria here. Okay, so let's check it out. We have a smooth outer membrane, which let's get our marker here. That's what we're seeing here. That's your smooth outer membrane going all the way around. All right, and then we have a second membrane, which is what you see in here. Second membrane. And remember when we talked about mitochondria, we said this implies an endosymbiotic relationship, that at one point mitochondria was its own prokaryotic organism. And then through endocytosis, it was brought in to a eukaryotic cell. And now it just kind of hangs out in there and gives off energy and the eukaryotic cell protects it from other organisms that would eat it. So that's our folded inner membrane. And each of those folds are called cristae. All right? So there would be a cristae there. There's another one. There's another one there. Another cristae there. There's one. There's another one. There's one again. All these folds are cristae, which is what they're trying to show us there. And then this space inside the cristae, this space in here, that's called the matrix. So let me try and hit all that up here. Okay, so what we're going to see is the electron transport chain is going to happen along the second membrane, while the Krebs cycle, okay, is going to happen out here. Right, so again, the point is the where. Where do these things happen? Let's get rid of the markers here. Okay, so our diagram, what we got going on. Again, we start out with glycolysis and we tear our glucose in half. What happens then is we send the pieces that are left from tearing it in half into the mitochondria. All right. Now, our mitochondria does a couple things with it. Some of it gets put into the Krebs cycle, and we get some ATP out of that. And then the pieces from the Krebs cycle get put into these things called electron carriers. Same thing happens with glycolysis. Those pieces get put into electron carriers. They eventually get put into this thing called the electron transport chain. So this seems kind of confusing, but it isn't really as hard as it looks. Imagine that glycolysis was a plate. When you smash a plate, you get big pieces and you get little pieces. Okay? So our big pieces, all right, we put into the Krebs cycle. And our little pieces, things like electrons and hydrogens, which are really little, we stuff into these things called electron carriers, which was the NADH, okay, and our FADH2. So they pick up the little pieces. Again, the hydrogens and the electrons. But the big pieces get stuffed in the Krebs cycle. Again, think about dropping a glass. You have big pieces and little pieces. All right, so again, our glycolysis happens in the cytoplasm, Krebs cycle in the matrix, and the electron transport chain happens at the cristae. So again, glycolysis in the cytoplasm. Doesn't matter if there's oxygen or not. We put 2 ATP in, okay, and then we end up with 2 molecules called pyruvate. That's what glycolysis gets us. All right, now here are those little pieces, okay. We end up dumping hydrogens and electrons into NAD2. All right, and we also come away with 4 ATP. All right, so let's go back here. All right, so again, we said when we break up glucose, we get big pieces, pyruvate, and we get little pieces. And here's our little pieces. All right, so, and this kind of gets into more detail about glycolysis than we really need to get into. So I'm not going to dive into that. Okay, we'll come back to this another time. Fermentation. So let's get to the Krebs cycle. All right, because again, we're only talking about aerobic respiration tonight. All right, that's Krebs. All right, so he named this biochemical pathway after himself. All right, he received the Nobel Prize for his discovery, and he was forced to leave Germany prior to World War II because he was Jewish. So that's just a little bit of the background of who Krebs was, and why the Krebs cycle is named after him, because he invented it. Okay, so again, what is the Krebs cycle? We said the Krebs cycle is going to get the big pieces, all right, from breaking the glucose. So this requires oxygen. That's what the first bullet point tells us. And it's cyclical. And that means it goes around in a circle. All right, so this is going to give off CO2, which we exhale. All right, we talked about that before. So we said we want to get rid of the parts of glucose that we're not going to use. So we're getting rid of carbon here, or we're getting rid of oxygen. Again, we only want the energy that's in the bonds. And every time we cycle around in our circle, we get 1 ATP. So one glucose molecule, we got to churn through the Krebs cycle twice to process it. When it's all said and done, we get 2 ATP, which is not very much. And this is just our location. Again, matrix of the mitochondria, where it happens. So oxygen has to be present. We give off CO2 because we're not interested in carbon or oxygen. We only want the energy. And we get a little bit of it. We get some ATP here, and we end up with 2 per glucose molecule. All right, so that's what the Krebs cycle does for us. Our summary, again, each turn of the Krebs cycle, little pieces. We pick up these 3 NADHs, FADH2s. Again, these pick up little pieces. They pick up hydrogen and electrons. All right, the rest of the big pieces go into the Krebs cycle. Okay, so as we crank through the Krebs cycle, what happens? What are we left with? So for every glucose molecule we stick in there, we get these 2 guys that pick up the little pieces. We get rid of 4 CO2s because we don't want that. And we capture a little bit of energy, not very much. All right, and again, this is the Krebs cycle, and we don't need to know all of these things, but we crank around through here, and again, you're just seeing here we're picking up small pieces, getting rid of the stuff we don't need, picking up small pieces, getting rid of the stuff that we don't need, getting a little bit of energy, picking up some more small pieces, picking up some more small pieces. Again, the glucose molecule is like a broken glass. There's big pieces and there's small pieces. All right, so that's what we get out of it. So now the million-dollar question is, what do we do with all these small pieces? Because we've been picking up small pieces for a while now. We picked up small pieces in glycolysis, and we picked up small pieces in the Krebs cycle, and we haven't gotten much energy. Okay, so how do we get all this energy? Well, we got to take those small pieces and put them into something called the electron transport chain. And this is the last part of cellular respiration. Okay, so this is where we get 34 ATP, which is a lot of ATP. All right, so this is where we're getting a lot of bang for our buck. Byproduct is water. Again, we don't want the hydrogen. We don't want the oxygen. We're only after the energy. This occurs in the inner membrane of the mitochondria. All right, and those coenzymes we talked about, NAD plus and FAD plus, that accepted electrons from glucose are back, and they need to get rid of those small pieces. All right, and we're going to see that when they get rid of them, we get ATP. When we get rid of the hydrogen and the electron here, we can get 3 of them. When we get rid of our 2 hydrogens and our electron here, we can get 2 of them. So we're going to start cashing these in and getting rid of these small pieces that we picked up. All right, so I want to kind of stop there. I don't expect that you guys understand this incredibly well. We're going to revisit this. I have an assignment for you guys to kind of go back and kind of sift through these notes a little bit and answer them. And next week we're going to get back into this. All right, and again, I'll let you guys know exactly what I want you to know. And we'll also go back and we'll cover the fermentation part and the anaerobic part, which is another way that we can get ATP. It's not nearly as complex as this, and it's much shorter. Okay, so if you have questions, which you should, I think that's pretty complex. That's one of the harder topics we cover in biology. Please email them to me so I can try and answer your questions. Again, we're not done with this. I don't expect that after watching this presentation just once that you understand cellular respiration. But hopefully you know that it has multiple parts. We only talked about the aerobic part. And the aerobic part has glycolysis. It has the Krebs cycle. It has the electron transport chain. And it occurs in the mitochondria. Okay? If you got that, you're off to a good start. So again, please email me questions. I expect you to have questions. You can watch this a few times. But we'll return to this idea. Okay, so it's just the first time. So don't get upset and don't get frustrated if you're not sure. All right, so again, that's it for the Krebs cycle and the electron transport chain for right now. Come on, where's the pointer? There we go.